In this lesson, we will be introducing quadratics. And so we are going to look over some patterns and rates of change and look at quadratics in terms of rate of change. And so here we have three different sequences of numbers, and we want to find out what the pattern is. So 15, 9, 3, -3, -9. You might notice here that each time we are subtracting 6 or adding -6. Adding -6, adding -6, adding -6. So when we are adding or subtracting the same number each time, that represents a linear function. And so a linear sequence of numbers has a constant rate of change, and in this case, the rate of change is -6. If we look at this sequence of numbers, we have 5, 15, 45, and 35. It's not going to be linear because we add 10 and then we add 30. Right? So it can't be linear. So you would notice that we are multiplying by 3. Since we are multiplying by 3 every single time, that makes this exponential. And so exponential sequence of numbers, they also have a constant rate of change, but this time instead of adding or subtracting, it is multiplying. So the constant rate of change for this one is multiply 3. And when you look at this sequence of numbers, we should notice we're not multiplying the same number each time. And when you find out what we're adding by, it doesn't even look like it's the same number we're adding by each time. But if we take the difference between these numbers, between 3 and 5, that's plus 2. 5 and 7, that's plus 2. Also plus 2 here. So this is the second rate of change. And this represents a quadratic function, a quadratic sequence of numbers, and this has a constant second rate of change of positive 2. So this means that in terms of rate of change, quadratics will always have a constant second rate of change. And so for the next couple problems, we just want to determine, is it linear, exponential, or quadratic, right? So remember, linear is adding or subtracting the same number, exponential is multiplying, and quadratic is the second rate of change. So let's go ahead and look at part A. So 33 to 132, it looks like that if we want to try to see if it's linear, we are adding 99. But then when we look for the difference between 132 and 528, that is definitely not adding 99 also. So it's not going to be linear. Maybe it's exponential. Well, we can do 132 divide 33, and that gives us multiply 4. So that means if they're all multiply 4, it's going to be exponential. Well, what's 132 times 4? That is 528. 528 times 4 is 2,112. So that means part A is exponential. And so for part B, we see here, let's check if it's linear. It's adding 11, it's adding 14, it's adding 17, and then it's adding 20. So it's not going to be linear, but if we take that second rate of change, we are adding 3, adding 3, adding 3. So that means that this function is quadratic. And this is what you'll be doing on the assignment today, identifying the different kinds of functions from tables. We could also use that same rate of change with graphs. And so by process of elimination, if you know what linear looks like, you know what exponential looks like, you can assume this is going to be a quadratic one, but let's explain why in terms of rate of change. So what we're going to do is we're going to look at the points on the actual graph that we can use. So these ones cross the corners, and let's just make a table of values. So we'll take this first point, that is -5, 9. Then we take this point right here, that is -4, 4. We have -3, 1. -2, 0. We have -1, 1. And then we have 0, 4. And lastly, we have 1, 9. So let's look at the rate of change. So between 9 and 4 is -5, or adding -5. This is adding -3. This is adding -1, This is adding 1, adding 3, adding 5. So when you look at the difference between those, what's between negative 5 to negative 3, right? That's plus 2. So we're adding 2 here. Negative 3 to negative 1, that's also plus 2. Negative 1 to positive 1, that's also plus 2. 1 to 3 is plus 2, and 3 to 5 is also plus 2. So that means this is the second rate of change, which makes this quadratic. So we'll see in the next couple of days that quadratic functions make this parabola shape. Last one, we have a word problem here, conducting a science experiment, counting the number of cells in a petri dish. At the beginning there were 16 cells, and then there were 48, and then there were 144. We would notice that this is not linear because this is adding 32, and then this is definitely not adding 32. And so we might notice that 48 divided 16 is multiplied by 3. 48 to 144 is also multiplied by 3. So this is exponential. Thank you for listening.